Alrighty, for this week's sprint, first of all, got the color vector improved along the lines that you were talking about last week. Asserts in the set values so that the input value is within the correct range rather than an inline silent if. Next up is a bunch of math tools. We've got min, we've got max, we've got interval overlap. I had a question about this one actually. So this one wasn't working correctly, and I don't know if it was just because I was interpreting the math that we talked about in class wrong. But this makes more sense to me just logically, and I'm not sure what the efficiency ratings between the two are. But this makes use of obviously the in interval above there, so it might be a couple more operations, not 100% sure. Also have a clamp, and then we start getting into collision stuff. So we've got it if there's a point in the B sphere, if there's a point in the ABB, and then collisions. I'll talk about that a little bit later, but first I've got the AABB volume put together. As you can see here, it's got double dispatch put together, and it also has a render function within it so that user side calls to render the bounding volume of a specific collidable will be easier. They can just call that as a single no arguments call, and it will route through to the correct volume. So here we have the update data for AABB, transform the point, check for max values, check for min values per each of numverts. Then the collisions. So the way I have the double dispatch set up is the interact with is the first dispatch call that calls the other intersect this. The plane intersect is the one that has each individual type of bounding volume and routes through to the correct collision. The render just passes through the render call of the correct type. So obviously render AABB for the AABB. It calls render B sphere for the B spheres. And then, okay, so collision, we can go back and show that stuff off. It's pretty much exactly what we talked about in class. So B sphere collision, AABB is interval overlaps along the three axes. Yeah, min 1, max 1, min 2, max 2. Sorry, I thought this was min 1 and min 1 again, but that's fine. B sphere 2 box is clamp the center of the box to the min and max points here, and then ask if it's point in sphere, which is of course just comparing the distance between the center and the point to the magnitude. Another question I had was the rate of efficiency between doing this and calling this over and over instead of this. I did this as basically a shorthand just so I wouldn't have to type out so many more keystrokes to get what I wanted done. But I'm not sure if it's more efficient or not because it obviously has to create new vectors for every time it comes into the function. And then the last thing, point markers. So I do have render point. It's just translating the one by one box and sets a color just like every other render. As for the project side of things, like I talked about today, I'm planning on doing a what is it? Behavior tree for for the user to use. Um, so that'll consist of an UBL that will have an attached behavior tree inside the code. Um, then what I'm thinking at the moment will be the user will add the base class of nodes to the tree. This is basically how we had it set up in the game AI class that I took. Was there was a tree that would run through each node in succession, and you could have either a complex node that is one that has subnodes, or a leaf node that didn't have any subnodes, just did its job and then returned whether it had succeeded or failed. So the tree routes through either uh, playing or like sending through the commands into each subnode in parallel, so both of them go at the same time, and the node will break out only if all subnodes have also failed, or in sequence. So it uh, sends the first subnode. If it succeeds, it continues on. If it fails, it breaks out immediately. And I would also provide some basic nodes and also leave that end exposed for the user to code their own nodes. So basic things would be like um, being able to move to a specific point, being able to detect a tagged object within a certain range, things like that. Um, and then obviously the associated other things that go along with that, like um, the move would require a nav mesh of some sort, which means that after terrain is done, I'll need to figure out how to generate a nav mesh dynamically um, onto any terrain that we have put into it. I'll get that written up for next sprint, but for now I've just got the general nebulous idea of what it's going to be. I think that's it for sprint number 2.